Hello, we welcome you to another class in our series Learn Data Science in the R language primer. Today we are going to look at strings. Strings are a group of characters enclosed in double quotes or single quotes. Internally, all the strings will be enclosed in double quotes, but when we write them in the program, we are free to use only single quotes to start and end or only double quotes to start and end a group of characters. When we have double quotes, we can have a single quote inside a string, and the other way around, when we have a single quoted string, we can have a double quote symbol inside it. We have a few examples of strings where S1 is a double quoted string which says start and end with double quotes. S2 is a single quoted string which says start and end with single quotes. S3 is again a double quoted string with a single quote inside it. And S4 is a single quoted string with double quotes inside it. So when we run the program and print these strings, you can see the output as shown in this slide. You can also see the screen where the R console or the R Studio is visible, where we have got this how to download and install the R console and the R Studio in our first lesson. For those of you who still haven't downloaded, we strongly recommend that you download and use the console or the R Studio to run these examples and see for yourself how they work. Now we are having a few examples of invalid strings. For instance, S1 starts with a single quote and ends with a double quote, which is wrong. S2 has got a single quote within a single quoted string. So the machine will take the single quote SINGLEQUOT as a string and give us an error for the rest of the character strings which we have. And the S3, we have got a double quote within a double quoted string, which again the compiler will not be able to interpret correctly. Once we run the program, we see errors as shown on your screen, where the machine identifies that these things are all mixed up, the quote characters for the string. You can see the output from the R console. You can see the double-ended string, the single quoted strings, and then the errors which it is generating. So remember the general rule: if a string is in double quotes, you can have a single quote inside. String is enclosed in single quotes, you can have a double quotes inside, but nothing else is possible. Once we have strings, we can carry out some operations on these strings. One of them is the function paste. Paste actually attaches strings one after the other. The word for that is concatenate. Concatenate means you're sticking the strings one behind the other. The syntax is you have any number of strings, specify an operator between the strings which are to be attached, and specify whether the space between the strings has to be removed. So we have the parameter collapse. If the value is null, then the space between the strings will be removed. We have three strings here, S1, S2, S3, which contain the words hello, world, and again respectively. That is, S1 is hello, S2 is world, S3 is again. Now first print, we are pasting these three strings together. The second print, we are doing the same thing, but we are asking the machine to insert a separator, which is the hyphen. In the third example, we are not having a separator, but we are asking the machine not to add any spaces either. So the output we can see is hello, the word world, the word again with spaces. Hello hyphen world hyphen again, as you can see in our earlier example. And you have hello world again without any spaces because the collapse was specified as null. The same output from the system, you have the output as shown in the earlier screen with the three words hello, world and again. We can also format the numbers and strings in different ways. So let's look at the syntax. It's the keyword format. X is the value which we are specifying. Then it's whether it's digits or not digits. Then we have minimum number of decimal places. Then we can specify whether it's to be in exponential notation, which is called scientific notation. We can specify the width of the field, that is the minimum size to be used for displaying the characters, and if it is short, blanks are added to the left. And you also have the justification, it's called justify, where you can use one of the keywords left, right, center, or none. So we have a series of examples. We have 9 digits with rounding off. We have taken the value of pi. Answer 1 is ANS 1 is 3.14159 digits equal 9. We display in the second display we have the same numbers in scientific notation where we have said scientific is true. In the third example we have the decimal places to be displayed where we have specified 5 decimal places, that's n small. The last one we have said we are converting it to a string where you are formatting this 3.14. In the first example on this screen, we have leading blanks added because we have specified the width as 6. In the next example, we have specified justification to the left where justify equal L. You can also center the strings by saying justify equal C. As for our program, this should be the output. The first output is the value of pi, the 9 digits. Second one is a scientific notation of the two values which is specified, 5 and 3.14159. We also have the number of decimals provided. We also have the centering of the strings and the justification with spaces. It's a long output, but as you can see from the R console, each of those commands was executed and the output is as shown on the screen. The next function we can look at strings is called the number of characters, abbreviated to nchar, the letter N, C-H-A-R. What this function does is it takes a vector as an argument and returns a number of characters. So in our example, we have taken the vector as hello world, it's a string. We have applied the function nchar and assigned the result to a variable called ANS answer and printed it. You can see the value 11. Same example taken from the R console, you still get the answer 11. Then we have another set of two functions where you are converting the characters to upper or to lower. That's the uppercase or the lower case. Function name being to upper and to lower. So we have taken the words hello and world again. So in our example, the answer is the variable ANS. It's been assigned the string hello world. You print the string which with the to upper function. So we see the string displayed using capital letters. The same thing if we run it with the to lower function, we see it displayed with the hello world in lowercase letters. The same output is there on your screen, which has been run from a small computer program in the R console. Substrings extract a part of a string, so we can take out any part of a string we want. The syntax needs the string which is called the vector, and you specify the start position in the string and the end position in the string. That is the characters which are interested in the start and the end position of those characters. So let's say we take the same example. We want to extract the letters between 4 and 8, both inclusive, in the string hello world. So when you print the answer, it will say LO space WO. You can see the same output from the R console where you can see the words LOWO. Great work. You have completed another chapter from the Learn Data Science series. Please feel free to visit all the earlier chapters or any of them which you wish to revise. We are always there to answer your questions. Send your mail to dadamsandhya@gmail.com. Trust yourself. You know more than you think you do.